Good afternoon, dear Linux colleagues and guests and friends. My name is Igor Kosenkov. I work in the company called Postgres Professional. I'll tell you about the option of protection against split brain in case of creation of two-node cluster of PostgreSQL. There are many classifications and kinds of clusters, failure-resistant clusters. Today, we'll talk about the cluster based on such packages as Crescent Pacemaker by Cluster Labs company and today we'll talk about such classification of clusters as the cluster with and without this quorum. What is a quorum? It's a concept according to which we say that there's a failure-resistant cluster has a quorum, and after the failure of a certain number of live active node multiplied by 2 more than the general number of nodes. If you look to the right, one node goes wrong, the 2 are left, 4 is more than 3. So we can say that we do have the quorum, and the cluster has the right to live. If we look at a cluster without the quorum, that's the drawing on the left-hand side, then at the very first failure, one of the nodes will go wrong, and the only remaining node still live. Well, here it will not suit the conditions. This cluster shall be considered failed, and the pacemaker, as a brain of this cluster, shall stop all the services and will get, instead of a failure-resistant cluster, will get a refusal of service. So in such cases, again, we're talking about the cluster without the quorum. In such cases, at building of such clusters, one should mention a special option so that this quorum is not considered. Why am I telling all this to that? Why do we need two-node clusters with no quorum? Of course, there's the practical value of a two-node cluster. Practical application. Imagine you're an admin and you have 3 physical service or 3 VMs. So according to the article written at Harbor or somewhere else, you build your failure-resistant cluster with a quorum just the way it should be. And it works very well. All of a sudden there's a failure. So node number 1, we've decided to put it out of operation. What happens next? Yes, the administrator continues to live in peace because we do not have the service refusal. We have the quorum, we have the services which are running, and they process the requests. But all of a sudden, in the middle of the night, the administrator wakes up with the thought, what about if one more failure will take place? So, if one more failure takes place, then such a cluster on the left will not survive the second failure. What should be done? The solution is simple. The administrator should, for a while number 1 is being fixed, it should be taken outside the cluster. We should reset up our correct 3-node cluster with the quorum into a temporary solution, 2-node cluster without a quorum. This may be done with a set of commands, or with a set of commands. If when we set up a cluster, we introduce number of like 10-15 commands, or like all the lazy administrators, we can do it with the help of a script. So that we start up the script and transfer the cluster from the 3-node into a 2-node one, we shall only need some 15-30 seconds, between 15 and 30. Of course, one may choose, we'll understand that the highly loaded systems, the idle time of 15-30 seconds is too much. However, one may plan at the time when the loads are lower at night time, then it may be done. That's one of the practical values of a 2-node clusters and their application. Also, there are other benefits. One may use the 2-node cluster with another benefit. One of the obvious benefits is that this solution is very cheap. If, say, for example, the administrator would like to conduct certain tests, if he's only learning about this technology, he cannot come to his boss and say, I need to buy 3 servers to be able to build a fail-resistant cluster with 3 nodes. He may do it with VMs and with the help of 2 virtual machines. The second option, the second, say, benefit of a 2-node cluster is as follows. Say, when we have certain physical servers which are not equipped with ILO or APMI functions. The functions ILO and APMI are used for management of servers, for operating of servers, and some budget solutions, cheap solutions, do not have this function. IBMI and ILO are used for organization of fencing process, that is, fencing against the failed clusters, so that we don't have such an unpleasant situation as a split-brain 2-node cluster with no quorum has a drawback. This drawback is that at a loss of operating link, managing link, or at the loss of connection between the 2 nodes, each node begins to have an independent life and believes it's the main one and considers the neighbor node to be failed. So in the network we have 2 masters, 2 couples of resources, and if initially in the beginning, when nodes are isolated from each other, all this lives okay, well, at appearance of an operating or managing link, that's the drawing on the right-hand side, the customers or clients that refer to the fail-resistant cluster are making requests in turns to the master number 1 and master number 2. Let me explain in more detail on what we get when we happen to have split brain and when in our network we'll have 2 masters and 2 resources. Hence we'll get 2 independent databases which initially, before the failure, used to have completely similar databases. After the failure, each database, the second hub, the pacemaker, which is the brain of the cluster, carries out the promote command, and the standby server, which was the synchronous copy, becomes a master. Hence, we get the following. We get 2 timelines, 2 databases, in which at different moments of time there is recorded part of the general common information. So requests may be coming for a record into the database at the time moment 1 and at the time moment 2. Different information is recorded in master 2. Hence, we get non-consistent databases that live independently, exist independently. Also, we get two identical virtual IP addresses. This is the resource located both here and here simultaneously. And we understand that there's a device, a commuter, that may also behave in the most unpredicted manner. If two different IP and MAC addresses appear, some commuters simply block such ports. We get either the refusal of service or two non-consistent databases. It should be mentioned that, of course, there's a remedy against such a situation. There are certain protection methods. Let's review the existing methods of protection against the split brain. The first is the Stoneth mechanism. I believe no translation is necessary. We shoot somewhere, and survives the one who shot the first time, who was the first to shoot. This mechanism is carried out using the iWare PMI function. The command is sent to a special network plate with its own operation system for reloading and for either switching on or off, or reswitching. All this is organized on the level of the brain cluster pacemaker, and this guarantees that at a certain point of time, we shall always have one master in the network with the database. There will never be the second master. The second option is more stringent. If there's a failure, the pacemaker switches off all the resources, and instead of a failure-resistant cluster, we get the service refusal. It's clear that there exist other interesting self-made scripts. Each administrator is trying to protect himself. Not everybody has motorcycles to arrive to work at 2 a.m. So I suggest my own method of protection against the split brain. What's the essence of this method? Pacemaker has a weekly documented opportunity to use the scores. The general two-mode cluster with no quorum is added with a certain external object which is not within this cluster, and this external object is, we simply check its accessibility. This may be done in any way. For example, I suggest to use the ping. The pacemaker has the object of ping type. It's an already developed available resource. Each of the two nodes produces the ping of the external object, and basing on the result of this ping, we do the counters. What should be done to carry out this protection? On this slide, I could write down all the pacemaker commands to be executed, but then the fonts would be too small. You would need the spine glass to see it on the slide. So all these commands have been described many times. They're well known, they're common. Let me just specify on the points that are important. First, we add the resource. As I've mentioned, this resource has the ping type. It's cloned. It's on two nodes. Next, number 2. We needed to modify the stickiness of the resource from the infinity to 500. The figure of 500 was, determined via experiments, by testing and trying. You may experiment with it, but, well, it's known. Next, you should mention the role of the second failed node. When this resource is equal to 111, we believe this node is failed and we switch all the resources to the slave mode. Next, there are screenshots that show the stand, the way it works, the way everything is switched. On the first node, we see it plays the role of the master. The second node is a synchronous copy. It has a precise copy of data from the first hub. The resource default pin set has the value scores 333. That means everything is okay. The external object is pinged. Everything is okay. Next comes the failure, the loss of the command link between the master and the slave. Yeah, in case you don't know, this is the removal of the command from Ceramon. This is the monitor that provides the condition of all the nodes and resources in our cluster. Here we see the exit of a Ceram node on the first node. The resource now is equal to 111. That means we don't have the access neither to the neighbor node nor to the external object. The condition of our PostgreSQL, well, it's stopped. That's the line that tells about it. Here we see the removal of Ceramon on the second node. You see that the pacemaker saw that the first node became inaccessible, so it gave the command promote, and this node became the master of the database. The pin set resource is equal to 222. It means we see ourselves and we see the external object. It's not a failure for us, so we continue to work. The most interesting point is what happens when link is restored between the X master and the external object. Here, the pacemaker, according to the rules that we have set for it, stops on the first node of PostgreSQL. The second node continues to work. The virtual IP resource is on the second node and it continues to work. The database is consistent. Everything works okay. It's necessary to mention that for the administrator, after this has happened, so the administrator, after this has happened, has to do 4 steps to restore the failed node and to again re-enter it into the cluster. First, one should stop the cluster with the command that you see on the screen. Second step, he has to clean the directory of SPG data. It's a variable. In each system it has its own position. Always set this position at setting at PostgreSQL. Next, he has to copy the utility of PG-based backup, so to have its complete copy. And second is to relaunch the cluster on a failure node with this command. Thus, it's returned into our failure-resistant cluster. Thank you so much for your attention, and I'll be happy to take your questions. Questions are welcome. Thanks for the presentation. Maybe a strange question. This 2-node cluster, why? Why not a 3-node cluster and pings? Something should be pinged, but this something may fail. Yes, this may fall, but we have something else that may not fall. We can introduce 2 external objects or 3 external objects. Let's reserve commuters. At building of reliable failure-resistant clusters, we do not only reserve our services, we also reserve the hardware. we have virtual machines at different hosts. We stack the commuters. We do different network devices and unite them into quantum devices. So failure resistance issues is a different topic in this case. You've asked, why is it necessary? Well, there was a great slide that explains the practical usage. This may be a temporary solution so that the admin can have peaceful life for several hours more. The second point is that it's cheap. And the third point, we're using the VMs. If we have physical service, we do it without the IPML function. And also, it's good from the point of view of testing. You can play with it in a beautiful way. The admin can play with it, study it. It's not a production solution. It's a solution for studying, for testing, for implementing at the stage of testing. That's the way to put it. Yeah, it's not production. Sorry, I missed that. Thank you.
Thank you. Any more questions? Good afternoon. Thanks for your presentation. So what if the net is here, but the base has fallen? So there is no nodes in the cluster. And if somebody captured a IP thing, do you check it? Well, IP capture can happen in this case. There are ways to solve this problem. Have you worked with commuters? Yes, there are many functions there to prevent IP capturing. Only in case if there is an access to the network equipment and to the gate. Actually, it's enough to have an employee who has an access to the equipment, and we need to set a task. Well, if the base has fallen, well, let's consider such a situation. If there is a stable cluster and the base has fallen, we have a synchronized replica. At every moment of time, it has a full and consistent copy of the master. So if the main base has fallen, we can do the promote command, and the synchronized replica can become the master. All the resources are moved there, and from that moment of time, we have a new timeline, and it starts recording new information into the database on the former synchronized replica. So in two-node option, the ping check, which you use to check the availability of nodes. So slave cannot understand whether master is lifted or not. For it is lifted because it is pinged. Well, if there is a particular failure, ping is not a decisive thing. So we cannot say that if we have ping, we are fine. Well, in case something happened, and if we don't have ping, then we are in a bad situation. This is the logic. Well, here we have only notification. Well, it's an additional sign, which will tell us that our external object is not accessible, and based on this factor, pacemaker makes a decision about what to do, whether to promote or just wait until we have a link. Maybe later on you can approach me and then I will tell you more in an informal discussion. Well, we have a similar scheme, and we have some files which help us to regulate the situation. Well, if you like, I can repeat. So if this sub base falls down on the master and we have an external object accessible in the synchronized replica, there will be a promote up to the master level, and everything some time for the last question to the speaker. I have two questions, actually. If we consider other alternatives of two-node clusters, well, can you explain why did you choose this scheme, this layout? For example, MongoDB, there is such a thing as arbiter. This is a lightweight node, so it can vote, but it cannot store data. So arbiter is more interesting. When you lose your external resource, both nodes will go down. Counters will fall, both nodes will go down. Well, protection is okay, but you lose cluster. This is my first question. The second is as follows. For two-node cluster, we can take an approach for different weights. We can have a quorum for one node, so it will be much easier, I think. I will answer your first question. When the external object disappears, there will be no additional measures for pacemaker to put down this node, so they will continue working. So the external object doesn't play any significant role. It's just an auxiliary factor. Given all other factors are in place, it will allow pacemaker to make a decision. If we had a failed connection with the external object and it is isolated. Did I answer your question? Yes, let's consider you did, because we are pressed on time. If you briefly answer the second question, we will be absolutely happy. Could you please repeat the second question? Actually, I was carried away with answering the first question. Well, if we set different weights, 75 by 25, well, let us have a nice quorum of one node. Well, we are considering a very severe case when master falls down. When replica falls down, it's not so important because the system is operating, but when master falls down, it's serious. So in this case, this distribution of weights doesn't play any role. So if the master falls down, we don't have to maintain it, to stay.